All right, so this is your review for your quiz. It covers sections P2 and P3. For our first ones, we're just simplifying these. We are given the square root of 125 minus the square root of 45. The whole idea with this one is to simplify those radicals first before you do any subtraction. So that 125, underneath that square root, you can find the prime factorization of it. It is 5 and 25. The 25 is 5 and 5. So your two 5s would pair up. The one that's left over would stay under. So that's going to be 5 square root 5. For the square root of 45, 45 is 5 and 9. 9 is 3 and 3. So again, you're looking for a group of 2. You have 2 3s. The 3 is going to come out to represent both of those, and that 5 is going to stay underneath the radical. So you now have 5 square root 5 minus 3 square root 5. These are considered like terms because they both have the square root of 5 attached to them. So you are going to combine what's in front and keep the radical. So 5 minus 3 gives us 2. Keep the square root of 5. That's just 2 square root 5. Same concept with number 2, except now we're adding these. So we have the square root of 32 plus the square root of 18. You want to simplify both of those radicals first. So that 32 is 4 and 8. 8 is 4 and 2. We're looking for 2 of the same numbers, so you do not have to break those 4s up. You can just combine them or group them. Pull one of them out. The 2 is left over, so it stays under. For the 18, you have 2 and 9. 9 is 3 and 3. You have 2 3s, so you'll pull 1 out. The 2 is left over, so it stays under. So you now have 4 square root 2 plus 3 square root 2. Same concept as the one before this. These two are considered like terms because they both have the square root of 2 attached to them. So combine what's in front of them. 4 plus 3 gives us 7. You keep the square root of 2 attached to it. That's 7 square root 2. For number 3, you have the cube root of x to the 4th power plus the cube root of 8x. That cube root of x to the 4th power, think of it as x times x times x times x. Your index is 3, so you want 3 of the same term. So that's going to give you x times the cube root of x. The 8 underneath the cube root of 8x, that is 2 and 4. 4 is 2 and 2. So you have 3 of the same term. So that's going to be 2 cube root x. From here, these both have the cube root of x attached to them. So you could leave it like this, or it would give you x plus 2 in parentheses times the cube root of x. The reason why you put the parentheses around the x plus 2 is because they are not like terms, but they are still both in front of that cube root of x. So the only other way to represent this x cube root x plus 2 cube root x would be to put parentheses around the x plus 2 times the cube root of x. Tomorrow on your quiz, I will let you give me either of those. I'd rather you give me what's highlighted, but I would let you put either of those solutions as your answer, and I would accept it. For number 4, you have 8x to the 6th power, b to the negative 3rd power, all raised to the 2nd power. I want to simplify what's inside of those parentheses first with that negative 3 as the power. So I am going to rewrite this as 8x to the 6th power over b to the 3rd power, all raised to the 2nd power. This power of 2 that's on the outside is going to apply to both the numerator and the denominator. So this is going to give you 8x to the 6th power squared over b cubed squared. The power of 2 on the top is going to go to both the 8 and the x to the 6th power. So that 8 squared is 64. The x to the 6th power raised to the 2nd power. We have a power raised to a power, so we multiply those powers. That gives us x to the 12th power. And then on the bottom, that b to the 3rd power raised to the second power, we multiply those powers to give us b to the 6th power. So altogether, that's 64x to the 12th power all over b to the 6th power. Now, number 5 has a lot going on with it. So we're going to take this step by step and follow our rules for exponents. Remember, when you have the same base and you are dividing, you subtract their exponents. I'm going to use that when we do this question. For 5, we have negative 3x to the 7th power, y to the negative 2nd power, z to the 5th power, all over 2x to the 8th power, y to the 9th power, z to the negative 4th power, all raised to the positive 4th power. I'm going to simplify inside before I do anything with that power of 4 on the outside. Use your rules for exponents. When we have the same base and it's on the top and the bottom of our fraction, we keep the base, subtract the numerator's power from the denominator's power. So this is going to give us negative 3 over 2 times x to the 7th power minus the 8th power, y to the negative 2nd power minus the 9th power, z to the 5th power minus the negative 4th power. And this is all raised to the 4th power. So working with the x value, you have the power of 7 minus 8. 7 minus 8 gives us negative 1. So that's going to be negative 3 over 2 times x to the power of negative 1. The y to the negative 2nd minus the 9th. Negative 2 minus 9 gives us negative 11. So that's going to be y to the negative 11th. Your z has the power of 5 minus negative 4. Double negatives turn to positives. So that's going to give you z to the 9th power. Again, this is all raised to the 4th power. From here, you got to put the x and the y where they belong in order to turn their powers into positives. So that x is going to go to the denominator, that y is going to go to the denominator. The only one that's going to stay in the numerator is that z because it's already raised to a positive power. So this is going to give you negative 3z to the 9th power over 2x y to the 11th power, all raised to the 4th power. Now you have to apply that power to both the numerator and the denominator. The negative 3 to the 4th power is going to give you a positive 81. Z to the 9th power raised to the 4th power, you're going to multiply those powers. You get z to the power of 36. In the denominator, you have 2 to the 4th power, which is 16. X to the 4th power, which is x to the 4th. Y to the 11th power raised to the 4th power. 11 times 4 is 44, so that's y to the power of 44. From here, your 81 and your 16, can't simplify those. Your powers, they're all positive. You don't have the same variable in the numerator and the denominator. So this 81 z to the power of 36 over 16 x to the 4th power, y to the 44th power is your answer. For example 6, you have the square root of 15 times the square root of 3. When we work with two square roots being multiplied by one another, you can just multiply what's underneath. However, why work forward when you're going to have to work backwards? I would find the factors of 15, which are 5 and 3. So this is the same thing as saying the square root of 5 times 3 times 3. It's understood that our index is 2, so we want a group of 2 of the same numbers. You have 2 3s. Pull 1 out, that 5 stays under, so you have 3 square root 5. For number 7, you have the square root of 10 times the square root of 30. Again, I would rewrite this as the square root of 10 times 30. That 30, however, has a factor of 10, so I would separate it to be 10 times 10 times 3. Literally the 30 just separates to be 10 times 3. From here, you're looking for the square root, so you have 2 10s. You can pull 1 out. That 3 is left over, so it stays under. So that's just 10 square root 3. For example 8, we have 2x squared minus 5x minus x squared minus 8x plus 3. Because there is a minus sign or a negative in between these two sets of parentheses, we are going to distribute that negative into the second set of parentheses and change the sign on each of those terms. This is going to give us 2x squared minus 5x minus x squared plus 8x minus 3. From here, we're going to combine like terms and write our answer in standard form. Starting with the 2x squared, the only other term that has the x squared is the negative x squared. So we combine those to get x squared. Next, we have the 5x, or the negative 5x, and the 8x. That gives us positive 3x. And lastly, we have that negative 3. Since this is already in standard form, we do not have to rewrite it. We keep it as the x squared plus 3x minus 3. For number 9, you have 5x cubed plus 4x squared minus 3x minus x squared plus 7x plus 2. So with this one, again, there's a negative in between. So we're going to distribute it into the second set of parentheses and change the sign on everything. So this is going to give us 5x cubed plus 4x squared minus 3x minus x squared minus 7x minus 2. Now combine your like terms. Starting with the 5x cubed, there is no other x cubed in there, so just drop it down. Next, you have the 4x squared, which matches with the negative x squared. Those combine to give us a positive 3x squared. Then we have a negative 3x and a negative 7x, which combine to give us negative 10x. And lastly, we have that negative 2 that drops down. This is in standard form. You have no other like terms to combine, so that is your answer. For number 10, we have negative 7x squared times x plus 3. So we're going to distribute this negative 7x squared into the set of parentheses that we have. So we're going to do negative 7x squared times x, which is negative 7x to the third power. Then negative 7x squared times 3, which is negative 21x squared. We do not have like terms here, so you can highlight that and that be your answer. For number 11, you have y times y squared minus 9 plus 3y squared times y squared minus 1. Or sorry, 2y minus 1. For this one, we're going to start by distributing the y and distribute the 3y squared. So we're going to have y times y squared, which is y cubed. Y times negative 9 is negative 9y. Then 3y squared times 2y is a positive 6y cubed. And then 3y squared times negative 1 is negative 3y squared. For this one, you do have like terms. You have the y cubed and the 6y cubed that you can combine to give yourself 7y cubed. From here, we would put this in standard form. So we would make sure that our powers would go from largest to smallest from left to right. So that's going to give us 7y cubed minus 3y squared minus 9y. For number 12, we have 3x minus 2 times 7x minus 4. We're going to simplify this one by just foiling. So we're going to do first, outer, inner, last. So the 3x times 7x gives us 21x squared. The 3x times negative 4 is negative 12x. The negative 2 times 7x is negative 14x. And the negative 2 times the negative 4 is a positive 8. You have like terms with this, with the negative 12x and the negative 14x. So combine those to give yourself 21x squared minus 26x plus 8. For number 13, you have 2x cubed minus 5 times x squared minus x plus 7. For this one, we're going to start with the 2x cubed, multiply it into the second set of parentheses. So we have 2x cubed times x squared, which is going to give us 2x to the 5th power. Then 2x cubed times negative x is going to be negative 2x to the 4th power. Then we have 2x cubed times 7, which is positive 14x cubed. Next, we take the negative 5, distribute it into the second set of parentheses. So negative 5 times x squared is negative 5x squared. Negative 5 times negative x is a positive 5x. And negative 5 times 7 is a negative 35. You do not have any like terms here to combine. So this is, the entire thing is your answer. For 14, you have negative 19x cubed minus 6x to the 5th power plus 7x squared minus 1 plus 3x. We have 5 terms here. So this is just a polynomial, a 5-term polynomial. So it asks you for the type, it would just be a 5-term polynomial. It does ask you for standard form. Remember, standard form, you are putting it in order from highest degree to lowest degree. So in this case, you're going to have negative 6x to the 5th power minus 19x to the 3rd power plus 7x squared plus 3x minus 1. The degree of their polynomial is the highest degree from the first term of their standard form. So from your standard form, the first term is at negative 6x to the 5th power. So the degree of the entire polynomial is 5. Your leading coefficient also comes from the first term in standard form. It is the number part that's in front of your variable from the first term. So that is just the negative 6.